So thank you all very much for joining us. Good morning, good afternoon, good evening, wherever you are in the world. My name is Steve Cicchetti, and among other things, I am on the board of the E-Axis Forum, and I'm the chair of the E-Axis Prize Committee. Today, we are happy to have Sarah Duffy, who's going to present a paper entitled Climate Change, Adaptation, and Sovereign Risk. And Sarah is the co-winner of the 2025 E-Axis Forum Research Prize aimed at young researchers on issues associated with climate and sustainability. As I said, I have the privilege of being the chair of this committee. This was the fourth year that it's running, and during the time that it's been running, we've been receiving impressive and increasingly high quality research submissions from young scholars. Each year, the selection committee process has been growing increasingly competitive, and this is a testament, I think, to the quality of the submissions. I'd like to express my gratitude to the members of the prize committee, Stefano Giglio, Galina Hale, Marcin Kacperczyk, who's with us today, Pierre Monin, Fernanda Necchio, and Esteban Rossi Hansberg. They all have helped with this. It's a lot of work, and I appreciate their help. As I suggested, the prize is continuing to gain recognition thanks to the exceptional expertise of my committee members, as well as the support from leading academic institutions, including Oxford, where Sarah is completing her PhD and actively promoting the work of our of the prize recipients and the submissions. This coming May 2026, we'll announce the theme of the 2026 prize, and I look forward to receiving another round of exceptional submissions that push the frontier of research in the field of climate sustainability and macroeconomics. Now, Sarah's paper is unusual in that it is about emerging market economies. Obviously, climate policy cannot just be about advanced economies, and the policy, which it often tends to be because of data and because people who write about it tend to come from advanced economies. It is also an advanced economy problem, obviously, but but the policies for, I think, less developed countries are extremely important. And as one person from a less developed country said to me a number of years ago, the policy prescription of advanced economies about what developing economies should do cannot be that they're not allowed to develop because of the fact that they won't, that they have problems with carbon emissions. So we're very excited to receive Sarah's submission. We were, as it concerns how it is that poorer countries are going to be able to finance adaptation. Now, Sarah, as I said, is a PhD candidate in economics at Oxford. She studies macroeconomics and finance and the effects of climate change and climate policy. And we're really looking forward to hearing from her. So, Sarah, over to you, and then we'll come back for the discussion. And in the meantime, if you have questions, just put them in the chat. If they're clarifying questions, I might interrupt. Otherwise, we'll hold them to the end. So with that overly lengthy introduction, here we go.
Great. Thank you so much, Steve, for the really kind introduction, and to the prize committee for this prize. It's a real honor. And thanks to Marcin for agreeing to be the discussant. I'm looking forward to hearing what he has to say. So as motivation, we know that climate change is projected to increase the frequency and the severity of many different kinds of natural disasters. And we also know that emissions abatement isn't going to be enough to stop that from being the case, at least in the medium term. And so because of this, increasingly, the attention of climate policymakers is turning towards thinking more and more seriously about adaptation, or investments that limit the damages from these disasters when they do in fact occur, to adjust to this new normal of a shifted distribution of disasters under climate change. And I'm going to think about hurricanes or cyclones as a running example of a natural disaster in this paper. These disasters are responsible for very large macroeconomic damages, And so there's a strong incentive for governments to invest in measures that can limit the damages from these events. And there are many ways that governments can and do this. For example, building physical infrastructure like seawalls to limit the effect of storm surges and damaging infrastructure that lies behind it. You might also think about reefs or ecosystem-based services like mangroves, which can work in a similar way by protecting infrastructure that lies behind them. Or we might think about other kinds of interventions like early warning systems or forecasting that allows people to move out of the way. And we know that each of these kinds of interventions can be effective at limiting the damages from these events, though of course at the same time these investments are costly. And we also know that many of the most disaster-prone economies are fiscally constrained or face high costs of borrowing on their external debt. So in the case of cyclones, cyclone activity is heavily concentrated around the tropics, where governments such as those in the Caribbean and Latin America might struggle to access finance. And so there's a concern that the economies that stand to benefit the most from adaptation might struggle to access finance in order to fund these kinds of projects. And this might be especially a concern as climate change itself is likely to increase borrowing costs for these economies by increasing the frequency and severity of these bad shocks, potentially precipitating climate-related defaults. And so increasingly then, leaders in these economies, these borrowing-constrained, disaster-exposed economies, have been making calls for debt relief for climate resilience, asking for the fiscal space that would enable them to fund the kinds of projects which will protect them from these disasters. So in this paper, I want to think about two things. Firstly, I want to ask, well, how does sovereign risk affect the ability of these governments to adapt? And what does that imply for the welfare losses from natural disasters and from climate change? And then I want to think about whether debt relief policies could be effective at limiting the channel that I'm going to outline. So the paper has three parts. In the first part, I'm going to set up a sovereign default model, which I'll augment with two additional features. The first is there's going to be an additional shock, which I'll interpret as a natural disaster. So at some probability, a natural disaster will occur, which will reduce the resources available for consumption. Additionally, I'm going to allow the sovereign to invest in adaptation, which will limit the damages from these disasters when they arise. In this model, I derive a number of analytical predictions, which I later take to the data, all of which together point to the idea of what I'm calling an adaptation trap. So the idea here is that economies who are constrained underinvest in adaptation. As a result, these economies then suffer higher damages from natural disasters, which in turn increases their borrowing costs further. So the paper points to this negative feedback loop between high borrowing costs, low adaptation, and high losses from natural disasters. I want to test whether the chains of that link in fact hold in the data. And in order to do that, I'm going to put together a new data set on adaptation expenditures by using text analysis methods to identify adaptation line items in government budget documents. And with this new data set, I'll document some new descriptive statistics. Most importantly for this paper, I'll document that adaptation expenditure is increasing in sovereign credit rating, consistent with the prediction of the model. Additionally, I'm going to provide some new causal evidence that hurricanes cause the probability of default to increase and show that that effect is driven primarily by those economies who have invested less in adaptation. So consistent with the model then, constrained economies spend less on adaptation, and due to this lower spending on adaptation, these economies suffer higher borrowing costs as a result of these shocks. I want to think about then, having validated the predictions of the model, whether any of this is quantitatively important and whether there's anything that can be done about it. And so I turn to the quantitative extension of the sovereign default model. I estimate this model to match a population-weighted Caribbean. And what I show is that adaptation investment as a proportion of GDP in the Caribbean is 13% lower than it would have been absent this default restriction. And as a result, the GDP effects of hurricanes are 10% larger than they otherwise would have been. And I show that this effect gets larger as climate change gets worse. In the final part of the paper, then, I want to think about some policies which might be effective at attenuating this channel. I'm going to think about two policies in particular. The first is motivated by the IMF's Resilience and Sustainability Trust, which was set up to provide long-term financing for adaptation. I'm going to model that as a default-free loan. I'm also going to think about a market-based instrument that might be effective in this situation. I'm going to propose, in particular, an adaptation-linked bond, whereby the coupon paid on a bond is contingent on the sovereign meeting some pre-specified level of adaptation. In particular, I'll find the spread minimizing adaptation bond to be very effective, and that it closes more than 3/4 of the gap in the GDP loss per natural disaster between my baseline model and the counterfactual without any default risk at all. So this paper is clearly drawing on many strands of the literature in environmental economics, in macro, in finance and development. So for time, let me not talk about all of those things, other than to say there have been some papers which have emphasized that climate change can exacerbate fiscal vulnerabilities. In this paper, I'm going to emphasize that fiscal vulnerabilities can also exacerbate the losses from climate change. As in my framework, the damages will be endogenous as a result of this adaptation choice that the sovereign is able to make. Okay, so I'm going to start by showing you a sketch of the sovereign default model. Then I'll turn to the data to validate it before showing you some quantitative results. So in the minimal amount of maths, here is an overview of what a standard sovereign default model looks like. So I'm going to assume that there is some sovereign that receives some stochastic stream of income from nature. I'm going to assume that this sovereign is benevolent, and so it wants to maximize the utility of the representative household. This sovereign makes two choices over borrowing and default. In order to borrow, the sovereign issues bonds, which are bought by a continuum of risk-neutral international investors. The friction in this model is that the sovereign can't commit to repaying this debt in the future. It has the option, instead of repaying, to default and suffer some output cost of default. As a result of this risk, then, these investors have to be compensated for holding on to this asset. And so the price of the bond is going to have a spread over the risk-free rate, where the spread will be related to the probability of default. To this standard model, I'm going to add two features. The first is I'm going to add an additional shock, which I'll interpret as a natural disaster. And the second is I'm going to allow the sovereign to adapt to protect themselves against this shock. So here at the bottom, I'm showing you the endowment equation, which lets me be a little bit more precise about this. The sovereign receives an endowment Y, which depends with some degree of persistence rho on the endowment in the previous period and on a standard endowment shock epsilon. Additionally, with some probability, a natural disaster occurs, and this indicator variable X is going to take the value of 1. In this case, the intensity of the natural disaster D is drawn from a distribution. So you can see then that the natural disaster reduces the resources available for consumption today, and also in the future as a result of the persistence of the endowment process. But as I said, I'm going to allow the sovereign to invest in adaptation, which here I'm denoting by lambda. And I'm going to assume that the more the sovereign spends on adaptation, the less damaging these natural disasters will be when they in fact hit. So this means I'm going to assume this function f is decreasing, convex, and satisfies the n-ada conditions. Okay, so I'm going to make a number of assumptions on this model, which will give me some analytical tractability. So in particular, for now, I'm going to say, assume there are only two periods, that there is log utility, and simple pro-cyclical costs of default. That allows me to derive some propositions in the model that for now I'm just going to show you in words rather than deriving them. So the first feature of this model is the standard feature in sovereign default models, which is that the spread is debt elastic. So the more the sovereign borrows, the more debt they have outstanding, the more they'll want to default because the more costly it would be to repay. Therefore, investors have to be compensated more for holding on to this debt, and so the spread is larger. So the more debt outstanding, the more constrained the sovereign will be. Additionally, in this model, the spread is increasing in climate change. So the more likely a natural disaster is expected to be in the future, or the more severe such a disaster is expected to be, the more likely the sovereign is to default. The more investors therefore have to be compensated for holding on to this debt, and so the higher the spread is, or the more costly borrowing is for this sovereign. Additionally, this model features adaptation, and adaptation will work in the opposite way. So the spread will be declining in adaptation by the same logic. The more the sovereign invests in adaptation, the less damaging these natural disasters are expected to be when they hit. The less likely the sovereign is to default, therefore, in these hurricane states, and so the less investors have to be compensated. So that's the optimistic message of the paper. It says that this idea of climate-related defaults that people have worried about might not be as severe as we thought, given there is also this incentive to invest in adaptation, which attenuates the effect of climate change on the spread. However, of course, how much this ends up mattering depends on how much the sovereign in fact chooses to adapt. And what I show in the paper is that for emerging markets, the choice of adaptation that the sovereign makes is declining in sovereign risk. So the more constrained the sovereign is, the less the sovereign will choose to adapt. This is because the presence of default risk restricts the ability of the sovereign to consumption smooth. They're less able to bring consumption forward in time, and it reduces their lifetime income. And as a result, the marginal cost of adaptation is going to be higher in this model with default risk than it would have been in a model in which the sovereign borrowed at the risk-free rate. Putting all of those predictions together, then we get this idea of what I'm calling the adaptation trap. The model says that high borrowing costs restrict the ability of the sovereign to adapt, so adaptation is lower. As a result of this lower adaptation, then, natural disasters cause greater damages for these sovereigns, which in turn increase their cost of borrowing further. So the model predicts this feedback loop between high borrowing costs, low adaptation, and high losses from natural disasters. I want to think about whether the channels in this model in fact hold in the data. And a barrier to doing this is that there isn't any existing data on aggregate adaptation across countries. So the macro literature has mostly used a latent variable approach, whereby the economist infers that adaptation must have occurred if conditional on disaster size, countries with a higher historical exposure to natural disasters suffer lower damages, or if damages are falling over time within a spatial unit. In this approach, adaptation is inferred, it's not directly observed, so we don't know what kind of adaptation is actually taking place, if any. Maybe you could tell different stories from why you might see these patterns in the aggregate data. Importantly, for this paper, in that setting, identification comes from panel variation with low power, and so it's not possible to compare the level of adaptation across countries or how adaptation varies with other country characteristics. So what I want to do here instead is to construct a direct measure of adaptation expenditure. And I'm going to do this by identifying adaptation expenditures in government budget documents. The idea is that these documents are a rich source of information on government spending by purpose, and so I can use them to generate a dollar amount spent on adaptation in particular. So how am I going to do this? Well, the technical problem is to figure out which keywords, which line items in government budgets correspond to adaptation. And in order to do this, I'm going to use an approach of transfer learning or keyword discovery that follows these 5 steps. So first, I'm going to supply a list of initial keywords which unambiguously describe adaptation. So I'll get a list of keywords from the IPCC Summary for Policymakers, where they have a table where they list the most common kinds of adaptation that governments engage in. Secondly, I'm going to build a large auxiliary corpus of adaptation-related text in general, and this is going to come from numerous sources, including Development Bank reports on adaptation and country reports to the UN on adaptation. In this large corpus of text, then, I'm going to construct word embeddings, where word embeddings people are getting familiar with now is the building block of the large language models we are all using. So a word embedding is a real valued vector representation of a word, where words closer to each other in the vector space are closer to each other in semantic meaning. So what this algorithm does is it gives a vector to each of these terms, which allows me to figure out how the meaning of each term relates to the meanings of the other terms in my sample. What I do then is I identify terms with high semantic similarity to at least one of the initial keywords. So I compute the cosine similarity between all of these embeddings to figure out which words mean something similar to at least one of the words I know are to do with adaptation. This is going to give me a final set of terms or a keyword dictionary. And I'm going to search for instances of this final set of keywords in government budget documents. This will help me identify the line items that correspond to adaptation. I hand read all of those flagged line items to make sure I'm not double counting anything, and to make sure that I record the monetary value associated with each of these line items. So in the end, what I'm going to have is a dollar amount spent on adaptation in each country in each year, which I can disaggregate by purpose. I'm going to do this for a sample of rated economies in Latin America and the Caribbean. I'll be restricted to those economies which write their budgets in English or Spanish for the reason that I'm using this natural language approach. And I'll also need those budgets to be in machine readable format. With this data set, then I can document some interesting descriptive statistics on public adaptation, which is something we didn't previously know much about. So what I find is that these economies spend on average 0.3% of GDP on adaptation. This is about 1% of total expenditures. This is a significant outlay, and it's about a tenth of what these economies spend on healthcare. So climate change is natural disaster exposure is clearly something these economies are concerned about and are investing in preparing themselves for. There's a substantial degree of variation across countries and over time. And as you might expect, I find that expenditure on adaptation is increasing in disaster exposures. The more exposed an economy is to natural disasters, the more they spend on adaptation. And it's also trending upwards over time. I can disaggregate this measure by narrower categories of adaptation. And what I find is that economies tend to adapt relatively more to the disasters to which they're more exposed. So in the Caribbean, for example, where hurricanes are the main risk, coastal protection is one of the main sources of adaptation. In Latin America, drought protection is very important as a result of the differing risk profile of these shocks. But what I'm interested in from the perspective of this paper in particular is the relationship between adaptation and sovereign risk and validating the predictions of the theoretical model I had up top. So here I'm showing you a bin scatter plot where on the x-axis I have the measure of total adaptation expenditure scaled by GDP, and on the y-axis I have an index of sovereign credit rating. So this is an average of the previous 3 years sovereign credit rating put onto a numerical scale, where a higher number is a higher sovereign credit rating or lower sovereign risk. And what you can see is that adaptation expenditure tends to be higher when sovereign credit ratings are higher, again, consistent with the predictions of the model. I can show you that as a regression instead. So here you can see that even controlling for GDP, exposure to natural disasters, and an index of government effectiveness from the World Bank, adaptation expenditure is higher when sovereign credit ratings are also higher. So in this specification, a 1 standard deviation increase in sovereign credit rating is associated with about $250,000 more spent on adaptation per year. In the second column, I show you a similar specification instead of the exposure and effectiveness controls with a country fixed effect to mop up differences in budgetary processes across countries that you might be worried about. And what you can see is that even within a country, there is this strong positive correlation between adaptation expenditures and sovereign credit ratings. So countries tend to spend more on adaptation in the times in which they are less constrained. Consistent with the model, then, there is this relationship between fiscal constraints and adaptation expenditure. Another prediction of the model, though, was that these natural disasters themselves increase sovereign risk, and that they do so especially for those economies who have invested less in adaptation. And so I want to test that prediction of the model in order to close this loop of the adaptation trap that I outlined a few slides ago. In order to do this, I'm going to use some physical data on the incidence of cyclones, which I'll get from the International Best Track Archive, which maps hurricane locations at 6 hourly intervals. I'll map these hurricane tracks back to country units to figure out which countries experience these events. And I put together this dummy variable, DIT, which takes the value of 1 if country I experiences at least one Category 1 hurricane in period T. And I'm going to match this data with 2 sources of data on sovereign risk. First, I'm going to get data on credit default swap spreads from Bloomberg. So CDS, you can think about as like insurance on the probability of default of the underlying asset. So if the probability of default goes up, the spread on the CDS should also go up. As this data is a little bit less available, doesn't have such good coverage, I'm going to also run my specifications using an indicator variable for whether sovereign defaults did in fact occur, for which I have greater coverage. And with this data, I'm going to run some local projections, which take this form. So the outcome variable here will be either the CDS spread or the indicator of default. And the shock will be this dummy variable for whether a cyclone occurs. The identifying assumption here is that conditional on a given country's climate and on trends in the climate, whether in fact a country experiences a cyclone in a given period of time is essentially random. And so this allows me to estimate the dynamic causal effect of a cyclone on the probability of default. What I'm showing you here is the impulse response function of the CDS spread to the cyclone shock over a horizon of 12 months. What you can see is that on impact, the CDS spread increases, so the probability of default increases. And this effect is persistent over a horizon of at least a year. So the cyclone causes this increase in the probability of default, which is persistent, again, consistent with the model that I showed you up top. The model also predicted that this effect should be larger for those economies who have invested less in adaptation. So I want to test that prediction of the model. I can't do that with the CDS data because the coverage between the overlap in coverage between the CDS data and my adaptation data set isn't good enough. So I'm going to turn to this data on the incidence of default instead, this default indicator variable. So here I'm showing you the impulse response functions of this sovereign crisis dummy to a cyclone shock where I'm splitting the sample. So the blue IRF is showing you the subsample of economies who have invested below the median in adaptation in my data set. And the red IRF is showing you the subsample of economies who have invested above the median in adaptation in my data set. And what you can see is that the effect of the cyclone on the probability of default is positive and statistically significant only for this subsample of economies who have invested less than the median in adaptation. So consistent with the model then, cyclones increase the probability of default, though they do so mostly for those economies who are less prepared for these events or have spent less on protecting themselves against these shocks. So putting that together, then we have the adaptation trap dynamic that I outlined for you towards the beginning of the presentation. But you might ask, well, is any of this quantitatively important? Is it something we really need to be worried about in terms of the welfare losses from natural disasters and climate change? And if so, is there anything we can do about it? So in order to answer this, I'll relax the simplifying assumptions I made up top and turn to the full infinite horizon sovereign default model, which I'll estimate to match the moments of a population-weighted Caribbean. So for time, let me skip the details of the calibration strategy and the model performance, other than to say the model does a good job of matching the data, even the untargeted moments. In particular, I'm leaving the impulse response functions I just showed you untargeted. I'm interested in how the role of default risk in explaining adaptation and so exposure to natural disasters. And so I'm going to compare the performance of my model to a counterfactual in which the sovereign doesn't have the option to default and so can borrow at the risk-free rate. So what I'm showing you here are some simulated moments in the first column for my baseline model and in the second column for this counterfactual without any default risk at all. And what you can see is that as a result of this default risk, adaptation investment as a proportion of GDP is 13% lower than it otherwise would have been. And because of this, the GDP loss per hurricane is 10% higher. So this default risk is a quantitatively important driver of the aggregate losses from hurricanes in this region. If I resolve the model in line with projected increases in the frequency and severity of cyclones by the end of the century, I find that this gap in the GDP loss per natural disaster between my model and this counterfactual increases to 13%. So this default risk friction is a quantitatively important driver of the losses from natural disasters today and likely to become more so as climate change gets worse. So we might wonder what can be done about it. In the model, I think about two policies. The first is motivated by the IMF's Resilience and Sustainability Trust, which is a new lending facility which was established in 2022 for the purpose of providing long-term financing for climate preparedness. I'm going to think about a loan from the IMF as essentially default-free for the reason that the IMF is the senior lender and so almost always gets its money back. And so I'm going to think about a loan which is 10% of pre-loan output, after which the sovereign is going to have to repay in perpetuity and won't be able to default. Here I show you some simulated moments of my model, the counterfactual without default risk and the counterfactual with the IMF loan. And what you can see is that the addition of this IMF loan increases adaptation investment as a proportion of GDP substantially. Even though this loan isn't targeted specifically for the purpose of adaptation, the sovereign chooses to use some of this influx in risk-free borrowing to spend on protecting themselves against climate change. And as a result, the GDP loss per hurricane is 4% lower than it would have been without this loan at all. So this IMF program seems to be quite effective in the model, even without any targeting, at inducing sovereigns to protect themselves against these disasters and so lowering the losses from them when they occur. However, of course, the IMF's balance sheet isn't infinitely unconstrained. And so we might wonder, what can private agents in the market do on their own in order to alleviate this channel? And so what I do is propose a new kind of bond, or an adaptation-linked bond. So there has in general been an increase in the prevalence of green bonds over the last number of years. These have largely been corporate bonds, and they've largely been use of proceeds bonds, whereby the proceeds from issuing the bond is tied to some specific purpose. Uses of proceeds bonds aren't always well suited to governments which have rules about the fungibility of government finances. And so we might want to think about instead outcome-linked bonds. And there has been a little bit of precedent for this. So in particular, Chile has issued a mitigation outcome-linked bond, whereby they pay a lower coupon if they miss their emissions reductions targets. I'm going to propose instead an adaptation outcome-linked bond. The idea here is that the sovereign pays the investor a C% lower coupon if they meet some pre-specified adaptation capital target. I've just shown you that in maths at the bottom of the slide. The idea of such a bond is that investors would like the sovereign to spend more on adaptation to protect themselves against natural disasters and reduce the probability of default. And so allowing an adaptation bond should reduce default risk and so lower the spread. At the same time, of course, there's a countervailing effect, which is that by introducing this bond, we make the debt state contingent, and lenders will require compensation for the fact that they receive a lower payment in some states of the world. In the model, I balance off these forces and find the level of the coupon reduction that minimizes the spread. It's 2.2% in my setting. And here I'm showing you the simulated moments of my model, the counterfactual without default risk, and then the counterfactual with this spread minimizing adaptation bond. And what you can see is that this bond is really effective at increasing adaptation investment. It increases by 10%. And as a result, the GDP loss per hurricane is 8% lower than it was in the baseline without any such policy. And so this adaptation bond closes more than 3/4 of the gap in the welfare loss, in the GDP loss per hurricane between my model and the counterfactual without any default risk at all. So putting all of that together then, this paper is arguing that sovereign risk restricts adaptation and so increases the costs of natural disasters and of climate change. Theoretically, I've outlined this adaptation trap in a framework which integrates sovereign risk, climate risk, and adaptation. I've put together this new data set on adaptation, which I think has many potential future extensions, and I'm excited about writing more papers on. For now, it shows this robust negative correlation between sovereign risk and adaptation. And I've shown quantitatively that this channel really matters, though there are things we can do about it. In particular, this adaptation bond is potentially a promising avenue going forward. So thank you, and excited to hear the discussion and any other questions.
That's that's great. Thank you very much, Sarah, for such a terrific presentation. That and within the time. Um, I'm very, very pleased to have Marcin Kacperczyk, who's professor of finance at Imperial College London, with us. As I'm sure all of you know, Marcin's is a leader in finance, climate finance research. He also has done quite a lot on financial intermediation and financial stability. Um, and he's a member of our prize committee. I'm not going to spend a lot of time talking about all the other things that you've done, Marcin, because I think we want to hear what you say. So thank you very much for being with us. And there are some questions that are in the Q&A, and I will get to those. And please continue to add more questions. Thanks.
Thank you very much, Steve, for giving me the honor to discuss Sarah's paper. And first of all, Sarah, I wanted to congratulate you one more time warmly for winning this award. We were very impressed by your work, and really, the presentation today you gave was very impressive. So I got even more convinced that you were the really worthy recipient of the prize. So of course, in such a short time period as I have, I won't be able to give justice to everything that you've done, as I said, you've done a great job presenting the paper, and I encourage everyone to read the details of Sarah's paper because there are lots of really interesting things in that paper. So let me give you a little bit of my overview and a few observations that I think you could maybe think about in your future work, and I hope you find them useful for your research going forward. So essentially, Sarah is asking a very interesting question, which is how is the sovereign default risk interacting with the climate change adaptation? And she does it in essentially a two-way approach. She thinks of it from a theory perspective, and then she tries to take some of the key predictions of the model into the data and see whether some of them work in the data. So here are the kind of two sub questions that one can ask relative to this main question, which is do actually climate-related natural disasters feed back into borrowing costs in default risk? And actually do fiscal constraint actually generate what she calls actually an adaptation trap for especially markets which are particularly vulnerable. And here emerging markets are clearly a very good example of this kind of situation. So as I said, Sarah does two things. So first, she develops a very nice model, which is a sovereign default risk model. And the model is embedded with this notion of natural disasters and endogenous investment in something that she calls adaptation. So there is this very nice chain of logic that is actually introduced within the model. So the key kind of mechanisms or results that come out of the model is that the climate change raises, when I say climate change, negative climate change event raise borrowing cost. At the same time, adaptation lowers borrowing cost because it actually reduces default risk. So there is this kind of fixed point that happens here. And then in the end, what actually happens is that companies or countries which are actually subject to higher sovereign default risk are constrained in their adaptation efforts, and that in the end actually amplifies their disaster losses. So that's what she calls this adaptation trap. And then she takes some of the key predictions of the model into a nice empirical setting. So the first thing Sarah noted in her presentation, and this is actually very important, is that these adaptation efforts generally are somehow a latent kind of variable. So you need to think carefully how to measure that. And I was very impressed by how Sarah actually took the novel AI kind of or textual analysis tools to construct her own kind of measure of adaptation spending using government budget data. And then using this kind of measure of adaptation, she looks at the data in two ways. First, she looks at the panel data and shows the higher sovereign ratings are actually associated with significantly higher adaptation spending. And then she has this kind of nice shock where she looks at the incidence of cyclones, and she shows that cyclones actually increase default risk, and the effect on that default risk is actually mitigated by the incidence or presence of adaptation efforts. So, as I said, there is also a very nice discussion of quantities. I think this is very important for the papers on climate, that we get a sense of what's the economics. And Sarah is actually very careful in her paper about doing that. So, as I said, in terms of directional effect, Sarah does find that sovereign risk worsens climate damages via underinvestment in adaptation, but more specifically, using the setting of the Caribbeans, she finds that this is roughly 10% of the GDP losses that are actually due to cyclones that are due to this sovereign risk channel. So I would say this is actually a non-trivial number, and I think it's clearly something that should be highlighted as the economic kind of effect of what's happening. And then also climate change again intensifies this channel and increases future losses. So there is this kind of notion of permanent effects that Sarah talked also about in her presentation. And then the second part, and I'm gonna give a little bit less justice to this, but not to say that this is not interesting. It's very interesting. Sarah tries to think how to get out of this trap, what it is that the countries can actually do in order, or what the communities or the global sphere can do to actually alleviate this kind of trap. And she proposes these measures of debt relief. So there were two that she talked about today. The one I really like a lot is this adaptation linked financing. So that reminds me very much of the work of my colleague Franklin Allen with Federica Zeni and Adelina Barbalu on the sustainability linked bonds. So I think it's very much in the spirit of this kind of target based financing. So she shows that this kind of tools have potential to actually relax the fiscal constraints. And to some extent, they also lead to actually increase in adaptation, reduction in default risk, and lower welfare losses. So as I said, this is a paper, this is something to flag as a wonderful research, especially from someone that young as Sarah. So my next slide is not going to be the usual kind of critique, but it's more to kind of highlight the points that I think I would like to maybe appreciate a little bit more, either in the model or in the data, or maybe together. So I titled this slide Ideas to Entertain, but again, these are just loose thoughts that I would say would be potentially useful to kind of explore, or maybe just clarify if this is just already in your thinking. So the first notion that I thought I slightly wanted more clarity on was this distinction between what we call adaptation and what we call recovery spending. So first of all, the model in the main kind of scheme is a static model. So of course, in a static model, there is not much of the kind of dynamics associated with shocks hitting and then subsequent investment spending and subsequently shocks hitting, etc. So in this regard, it's clearly absent there. But I think from the perspective of what we really have in mind when we think about adaptation, I think to many people, adaptation typically is something that is more of a kind of ex-ante investment before you get hit, vis-a-vis something that, as I call here, recovery spending, which is more like investment in basically infrastructure subjected to already the damage. So I think if the paper could shed a little bit more light on that distinction, that would be very interesting. And especially so, where I would like that to be very explicitly kind of considered this empirical setting. So as I mentioned, there is a non-trivial task in the paper, and Sarah takes that to kind of measure what adaptation means. But I would like a little bit more validation and some kind of confirmation from this data, whether you are actually able to distinguish what we call the kind of pure adaptation versus what we call recovery spending. And I think it's important because in a sense, some of the spendings will be almost like forced. I mean, some rebuilding has to take place if damage already happens. Whereas when we think of adaptation, this is a little bit more like a voluntary choice, at least in the first kind of adaptation setting. When we observe seawalls or some kind of dikes being built in London, New York, etc., typically it's not because these places have been severely damaged and people are trying to actually rebuild it. It's more because they don't want to observe the damage in the first place. So I think that's kind of where I would like a little bit more clarity on, and maybe thinking about the future. And then there is maybe a related thought, but I think it's kind of also useful from the perspective of identification and thinking of the model, which is to what extent adaptation actually responds to, or adaptation investment responds to ex-ante versus exposed effects. So again, I think on the exposed basis, this is more along the line of this recovery spending. Ex-ante is more like in terms of like preparing for something or preventing something at the get-go. And related to that, I think it would be interesting, at least for me, to distinguish between events which are predictable versus not. We are talking about Caribbeans, especially here in the empirical setting. And I think it's fair to say that a lot of these events are to some extent highly predictable. The cyclone paths are quite predetermined, at least for some time. Maybe the scale of the damage is not always fully internalized, but I think the expectation that the damage can happen is clearly something that many of these countries grapple with. So to some extent, when we make comments like, oh, countries are investing in adaptation rather than other GDP related items, I mean, it's not always obvious how to make these things totally independent of each other, because big parts, of course, of these economies are kind of related to the cyclones and the whole production and everything that these countries do. I think necessarily have to internalize this kind of events. So maybe that distinction between predictable versus not is going to kind of allow you to separate this kind of welfare effects in the data. And then maybe more along the lines of the model that you built, I would also like to understand a little bit better from the modeling perspective, how important is this notion of irreversibility of investment? So if I understand the model correctly, the model kind of implies structure that whatever is being actually already spent on adaptation is the capital that we can actually not get back. But you could think that there is a setting in which actually some of this capital could be recovered, and then this adaptation trap that you talk about could actually potentially become less severe. So there is no like kind of cumulative effect that you highlighted in your presentation, but there is more like I can actually move resources across states and across time in this particular world. So thinking a little bit more maybe in that model, how would the model adjust to this kind of change of an assumption would be something that would help the reader visualize what are the real frictions and constraints that actually cause some of these risks. And then a little bit of something you are already talking about in the paper, which of course the natural question is what breaks these cycles? What can we do to actually come out of this trap? So as I said, the paper does a lot of great things in terms of this debt reliefs. I mean, there's the only questions that kind of came to my mind, broadly speaking, is how costly these things are. Is it really like always have to be discounted or almost like a donation, or is it that there is actually something that these countries can actually offer to pay for that? So here I thought for this about this debt for climate swaps that are very popular from the perspective of biodiversity. So maybe as a third tool, in addition to the two that you have already considered in your setting, that's another one worth at least discussing in the paper and trying to highlight how effective this kind of swaps could potentially be. And finally, I think there is this challenge that you highlighted, and I sympathize with that, of working with the aggregate data and how to actually identify things independently. I think the fact that we are talking about the same kind of regions, to some extent the same type of economies, is not always helping with identification. So I was wondering if there is any kind of space within your setting to think about the disaggregated data. And that is in two ways, in some sense. One way to maybe sharpen the identification of your framework, but also as a different kind of lead to maybe think about how these things actually distribute heterogeneously within countries. So in some sense, right now, the framework is kind of everything is homogeneous. Everyone in the country suffers, but maybe there is some kind of cross subsidization. Not every area is getting hit exactly the same way. And maybe there is some kind of fiscal capacity locally, local budgets, etc. So, or maybe even some powerful companies or foreign companies that can actually alleviate some of these constraints. Whatever you could maybe bring in on this, maybe this is for the new project. I think I would be very curious to see what we can learn from this kind of disaggregation into the communities and individual kind of players. So overall, let me conclude by saying that this is a framework that really thinks about big picture and important questions. So this notion that climate interacts with the sovereign risk and adaptation is vital are clearly tightly interconnected. And as I mentioned, I'm not going to repeat it. You do a lot of great work in this paper to highlight how this potentially creates this adaptation trap. I think the results that you presented are convincing. I very much like the discussion of quantitative kind of reconciliation of some of these effects, and the section on the debt relief is fantastic. Overall, all I can say is that this is the first paper to some extent, or one of the first papers that changes our views how we should think about climate vulnerability, not just as a pure physical risk, but something that actually interacts with the fiscal situation, financial stability. So I again congratulate you, Sarah, on doing such a fantastic job, and I encourage everyone again to go and read Sarah's paper in detail. Thank you so much.
Thanks, Marcin. That was absolutely terrific. We have a number of questions in the Q&A. Thank you all for putting them there. Let me you can weave your discussion and responses to Marcin in with questions. Let me try and put a couple of them together and with something else that I've been thinking of. I also want to just start. I'll start with things about green bonds and also potentially something related to something that Marcin said, which is about related to sort of about spillovers. I think about neighbors as well. So one of the I'll come to the bonds in a second, but one question that comes to mind always when I think about this comes from thinking about what happens. Maybe this isn't a country, but thinking if I live on if I live on the shore, if my neighbor helps me build a seawall, I'm going to be better off than if I just build it by myself. I actually have a friend who had this happen on one of the Great Lakes in the United States, which was eroding, and without his neighbor, it wasn't going to do anything because it was just going to, he could do it by himself, but it doesn't make any difference. It was still going to erode. He was going to be gone too, regardless of if he just did it by himself. So that's one thing, and related to that is this question of distribution. This is sort of between and within countries, and the issue of spillovers that are occurring. One of the questions had to do also with sort of a more technical one about measuring adaptation and local governments versus federal governments. I mean, you can answer that one as well, but I think that these are sort of questions, and then we can come to a question about the actual structure of the bonds in a minute. So why don't we, if you have some responses to Marcin, and then this question about, distributional things, neighbors, and the like, because I'm sure you've thought about all this.
Yeah. Thank you so much, Marcin, for the discussion, and yeah, also for this question. I mean, a lot of these things are great ideas for super interesting extensions to the model, which I have thoughts on, but don't exist yet. So it's great to collect these ideas and have ideas for what to do next. On this distinction between adaptation and recovery, I think this is for sure important. You would think that whether you do ex ante adaptation or recovery, that would probably have very different impacts in terms of how foreign investors would see you and your exposure to these risks. And so it for sure matters that we separate these things out. In the data, I try and do that. So something which comes up a lot in these budgets is a recovery for specific Hurricane X. I exclude those from my data set, but I have tagged them and I have recorded them. So at some point, it would be interesting to go back to this data and see the differential effects of adaptation versus recovery. In the model, of course, I don't have that explicitly, though the model is dynamic. And so there is a response of the adaptation choice to shocks. So in particular, you will spend less on adaptation investment if you become more constrained. And one reason you might become more constrained is because a big hurricane hits you. So that is there, but the recovery isn't there explicitly. I think this disaggregation is also super interesting. For countries in the Caribbean, I mean, there isn't a lot of devolution to municipalities, for example, but in Latin America, for sure, this is something which is going on. What was interesting to me, which wasn't obvious ex ante, is that there's actually no correlation in my data set between the number of line items that I pick up from the algorithm and the dollar amount I get in the end. So the results don't seem to be driven by differences in the detail in these budgets or like differences in devolution. And this country fixed effect also tries to pick up some of that. But it would be super interesting to go more disaggregated, look at these municipalities, municipal bonds. Maybe another interesting to go to see how this is priced in terms of fiscal capacity of smaller geographies. So that's, I guess, the disaggregation. The other way is to go international. I think this is also interesting. So you might think that there's gains to be made from risk sharing across sovereigns. At the same time, if these shocks are very highly correlated, maybe that's a little bit difficult. Um, Something I've been thinking about a little bit is if you think about, well, as Steve was saying, if you think about building a seawall, it matters what your neighbors are doing. It matters that your exposure is in some sense endogenous also into your neighbors' adaptation and not just yours. On the private level, I guess people have been thinking about this more and more with the wildfires that we've been seeing. So I think this problem is one you could think about on many different levels. And it would be definitely interesting to think about disaggregating the measure, to think more seriously about these private decisions or these spillovers across geographies.
Right, because the private, actually, your model does imply that private investment in adaptation would also reduce sovereign risk, right?
Hmm.
So,
Right.
so that's seems totally reasonable. There are questions about the structures of the bonds. Just by the way, the paper that Marcin referred to by Adelina Barbalo and Federica Zeni was a winner of the prize last year. So
Mhm.
that's a paper that we also really like, and so whether you've thought about there were some questions. There were some questions about the. I'm not going to get to everyone's questions, and now I've lost track of the questions about the structure of the bonds. But I guess there are two basic structures which the Barbalau and Zeni paper talk about. One of them is promises on what you're going to do with it, ex ante promises, and then one of them is ex post promises. So you're focusing on only one of those, I think, in your suggestion. Could it be the other as well? Or is there a reason that you feel this is going to work better?
Sure, yeah. So there's no promise on what you're going to do with it in my model. So it's um the structure of the bond is just if you reach the target, you pay a lower coupon. There's no sort of link between the income from the bond and what you spend it on. And the reason I've done it that way is my understanding is a lot of governments don't love these links, these use of proceeds type structures of bonds, and that it ties their hands, and they might have legal requirements of fungibility of government finances across different purposes, which makes it difficult, which is the reason I wrote the bond in this way. It would be interesting theoretically to think about if you get the same result if you wrote it another way. My hunch is you would get maybe a stronger initial kick because you have this money precisely funneled towards adaptation. But I think a nice feature of the way I've written this bond is that once you meet this adaptation target, the coupon payment on all of your debt is lower, and so your budget constraint is just weaker in general. And I think that's part of why you get these quite large effects in my model, which is
Yeah,
nice.
do we
Uh,
have examples of people trying to issue these? I mean, the thing you were referring to earlier, I think may be a big legal impediment, which is the pari passu requirement across different bonds. So you may not be able to issue a bond that's weirdly not fungible with another one, right?
right.
Um,
Yeah,
is
so I mean, there has been a history of state contingent sovereign debt, which hasn't always ended very well. So
right.
I guess you have the history of inflation-linked or GDP-linked bonds, which hasn't always worked out so well when statistics can be manipulated, for example. I think one nice feature of these adaptation-linked bond is that in theory, whether you in fact build the seawall is a little bit more observable than the level that your GDP is or your national accounts are today. I think uh, that's one feature that might make these more implementable in practice. Of course, there is a potential free rider problem, which I'm ignoring here. So in my paper, I assume that all of the bonds become adaptation bonds. Um, if that weren't true, if some fraction of the bonds were adaptation bonds, then everyone would like not to own them, but for everyone else to own them. In that means the sovereign adapts more, but you don't get the lower coupon. And so
Right.
I think in practice, you would need some design whereby some fraction of the bonds are adaptation bonds, and in order to buy a regular bond, you have to also buy some fraction of these adaptation bonds or some such design. So I think there are definitely practical issues to be worked out with people on the ground. I mean, and people at the IMF, for
Yeah, no,
example.
I think that's a great point because one of the big problems with green bonds is that companies that are engaged in both brown and green activities have the brown bonds and the brown activities free ride on the green bonds, and that's not great. We've unfortunately hit our time, and I've done a terrible job. I'm really apologize of getting to the questions that other people have asked. Some of them are really fascinating. I think that I believe it's possible for us to save the Q&A and send it to Sarah. And we can do that with hopefully with the names. And I also know that you're pretty easy to find, and my guesses are happy to have conversations with people about
For
their
sure.
questions. So what I do want to do is thank everyone. We've obviously had a terrific turnout for this, and that's I think testament to the quality of the work, Sarah, that you're doing, and we look forward to what you do next. And I think that Marcin has outlined a research program for you for the next few years, because this paper I hope is finished. And and we're not suggesting that you go and reopen this. That's not the suggestion at all. So thank you all for coming, and thanks, Marcin, for your discussion. And I hope that you're all on the mailing list for the eAccess Forums. Um, uh, eAccess Forums webinars and newsletters and the like. And that those of you that qualify and have papers will send them in for our next competition. And those of you that don't will tell your friends and your students. So thank you all very much, and have a good rest of your day. Bye bye.
Thank you.
Thank
Bye,
you.
Steve.
Bye.
Bye.
Bye. Thank you.